this section, we are going to find the equilibrium point. Equilibrium point is a place where the particles remain stationary in the rotating frames. Remain stationary, this means sum of forces is equal to the zero. So if you consider the location of the x-axis, two forces is acting. Centrifugal force is draw the yellow curves, and the gravitational potential is drawn by the blue curves, and the sum of the potential is written with the red curves. Then force is given by the derivative of potential with respect to the x. So these 3 points, you can easily recognize. These 3 points is around u, round x becomes 0. So this means force on these 3 points is 0. So on the x-axis, we easily find out there are 3 equilibrium points, L sub 1, L sub 2, L sub 3 point. 3 points on the x-axis. Then we'd like to consider the equilibrium point out of the x-axis. Then 3 forces acting on the particles, 2 gravitational forces, and 1 centrifugal force. Centrifugal force is anti-parallel to the B. B is the position vectors of the center of mass. This is the position of the center of mass. And the F sub 1, the point becomes the equilibrium point if the sum of the 3 forces is 0. So 3 force is F, and F sub 1 and F sub 2 becomes 0. So this is a gravitational force, and F is a centrifugal force. If the 3 force is 0, it becomes this point becomes an equilibrium point. So we don't consider the Coriolis force because Coriolis force is only effective when the particle is moving. But in this equilibrium point, there is no motion. So Coriolis force becomes automatically 0. So let's find the equilibrium point. So first condition is this is B is expressed. A is a position vector of the object m with mass of the m sub 1s. B, C is a position vectors of the object with mass of m sub 2s. So center of mass B is expressed this equation. So from this equation, maybe we can write an equation on the m sub 1 A vector minus B vectors is equal to m sub 2 B vector minus C vectors. If you consider the vector product with F, m sub 1 F cross A minus B vector equal m sub 2 F cross this cross product with F. So F is parallel to the B. So this means cross product of F cross B have to become 0. So from these equations, you can find that m sub 1 F cross A equal minus m sub 2 F cross C. Then for the equilibrium point, F have to be equal to minus F sub 1 minus F sub 2. Then F sub 1 actually parallel to the A vectors. the same reasons, f sub 1 cross A vectors is 0. And f sub 2 is parallel to the C vectors. So this means f sub 2 cross C is also 0. Then you can substitute these ones by considering these relations. Then this equation is expressed minus m sub 1 f sub 2 cross A equal m sub 2 f sub 1 cross C. So you can write under these equations. Then you can express the f sub 1. F sub 1 equal g m sub 1 m over a cube a vectors. Gravitational force acting between the m and the m sub 1s. F sub 2 equal g m sub 2 m over c cube c vector. Then you can substitute these equations. F sub 1 is here, f sub 2 is here. Then it becomes 1 over a cube minus 1 over c cube a cross c equals 0. So I skipped some calculations. Then this is not 0. So from this equation you have to conclude A have to be equal to the C. So distance of the equilibrium point to the bodies m sub 1 and m sub 2 are equal. A equals C. We derives. Then we consider the triangles. So now A and C is same A. If we consider cosine alpha, this is alpha, angle with alpha. Then if you consider these triangles, this is a half, so r sub 1 2 over 2. If you consider triangles, cosine alpha is r sub 1 2 over 2a. You can easily calculate. The beta is this angle. B cosine betas. This is the length of this one is B. B cosine beta. This length is A minus this length. So also maybe it's better to write down this length. This length is expressed m sub 2 over m sub 1 plus m sub 2 r sub 1 2. This length is m sub 1 over m sub 1 plus m sub 2 r sub 1 2. So this length times cosine alpha becomes here. So you can find that B cosine betas. And for the cosine alphas, you can substitute here. And also you could consider this triangle. This length is A minus this cosine alpha. Okay, you can easily understand. Cosine rules we can apply it. For these triangles, B square equal A square plus this length squares minus 2 times A times this length times cosine alpha. This is the cosine rule. So if you substitute the cosine alpha from here, you can get the equation. So this is the equation 1. For example, this is equation 1. This is equation 2. This is equation 3. If you consider these three equations, we apply in the next slide. So force balance actually required for the equilibrium point m omega square b. This is a centrifugal force. Force should be equal to the gravity. For the gravitational force, F sub 1 equal G m sub 1 m over a squared. F sub 2 is a G m sub 2 m over a squared. So actually F sub 1 and F sub 2 substitute. Then omega squares can be expressed in this equation. And the b cosine omega, b cosine betas, we can use equations once. So this equation, you can substitute this equation. For the equation 2, also we could use these equations. Is the equation 2 for this equation 2. Okay. Then omega squares can be expressed this one. Then we have already discovered the equation 3. This is equal to the a square minus this quantity is a b squares. This is the equation 3. If we apply it, the b square is cancelled out. So omega squares becomes this quantity. And then from the definitions of the omega squares, we have already discovered these quantities. Then from these quantities, R sub 1 have to be equal to the A. Okay, by considering the triangles, we finally reach this conclusion. Equilateral triangles. Equilibrium point is located this point. This is pi over 3 radians. So this is 60 degrees. 60 degrees. 60 degrees. This is 60 degrees. 60 degrees. 60 degrees. So we use geometry to find the Lagrangian points, which are equilibrium points. Okay. So we discover the 5 equilibrium points we called Lagrange points. So this is the end of this session.